iC-Haus. Integrated Circuits.
Good morning, good day, good afternoon. Welcome back to iC-Haus webinar series. Today I'm joined here at the table with Marcel Reuter, who's going to talk to us about the one cable technology and iC-BL BiSS Line. Before I pass over the word to Marcel, I just want to show you the webinar tool so you can see what functions we have here. So you have a control panel. If you click on the red arrow, you have various functions that you can use. And the most important function for today is the question and answer session, which you have a box here where you can put in your questions. They will be forwarded to the webinar team here in Bodenheim, and I'll read out your questions at the end of the session. So please take time and ask questions, because this should be an interactive session and Marcel is well prepared to take your questions. We also have two screens here. The top screen shows the actual presenter, in this case Marcel, and the bottom screen the presentation. In the middle you have a cursor which you can move up and down so you can size which screen you want to see in large mode. But please be aware when you use this function not to go all the way up, because then you might lose the speaker window, so just be careful when you move up and down. So without further notice, I would like to pass on the word to Marcel, who's going to show us today's presentation. Welcome, Marcel.
Thank you, and welcome from my side. My name is Marcel Reuter, and at iC-Haus I'm responsible for sales and application of BiSS interface products and protocols. Today I'm going to present you a robust one-cable technology, so in order to transmit power and data using BiSS Line. All right, let's check out the contents of today's presentation. I will start with an introduction about BiSS Line, present you the most important key facts, and then focus on the two types of BiSS Line frames. Then I'm going to focus on the bridge component iC-BL, present you some applications where iC-BL can fit into, and then present you the available evaluation kits. Afterwards, I'm going to present you in a live demonstration a typical setup for a BiSS Line slave evaluation and for a BiSS Line master evaluation. In the end, I'm going to summarize with one slide the most important key facts that you should take away from today's presentation. So let's start with the BiSS Line protocol. And first of all, I would like to check the established and available BiSS C protocol. It is a fast serial protocol for isochronous data acquisition and enables a permanent bidirectional control communication, which can be used to configure and calibrate connected BiSS C sensors and actuators. BiSS C requires 6 wires. There's one differential pair of wires for the clock signal transmitted from the BiSS line, from the BiSS master to the BiSS slave, one differential pair of data for the data transmitted from the sensor back to the master, and there are 2 wires for the supply voltage. BiSS Line is also a fast serial protocol for isochronous data acquisition and enables a permanent bidirectional control communication. Compared to BiSS C, BiSS Line requires only 2 wires, since data and power supply are modulated. One important fact about BiSS Line is its robustness. And I'm going to show you the techniques that BiSS Line uses to enable a robust data transmission. So let's check out some more facts about BiSS Line. BiSS Line is a one-cable technology for transmission lines of up to 100 meters length. It is suitable for 2-wire and 4-wire communication, while the 2-wire communication requires only some additional coupling elements for the modulation of the power and the data signal. BiSS Line enables a balanced transmission line. That means that high and low levels are distributed equally. This is achieved by an 8-bit 10-bit coding, which is used on the BiSS Line. To ensure that this 8-bit 10-bit coded symbols are fit to our BiSS C transmission, which is typically up to 10 megahertz of clock frequency, we use a fixed 12.5 megabit per second bitrate. BiSS Line is fully compatible with the BiSS C protocol. and is suitable to connect multiple devices to one BiSS master. That can be several sensors and actuators connected to one BiSS slave, and several BiSS slaves connected to one BiSS master. BiSS uses a forward error correction to correct data which had been corrupted during transmission. Last but not least, BiSS enables a low position jitter, and I'm going to show you which technique is used to achieve this. So let's check out the two types of BiSS frames. There's the process data frame, which is used for the sensor and actuator data transmission. And the process data frame is also used for a control communication with 1 bit per process data frame from the BiSS master to the BiSS to the connected sensors of a BiSS slave and vice versa. So the functionality of a process data frame corresponds to the functionality of the BiSS C protocol. In BiSS there's another type of frame. It's the auxiliary data frame, which is used to access the registers of a BiSS slave. Therefore, configuration of a BiSS slave is possible, fast reading of an electronic data sheet, and the auxiliary data frames are required to establish bus topologies. Let's take a closer look on the process data frame. Here you can see a process data request event on the top, which is transmitted from a host microcontroller to the BiSS master. In the center, you can see the BiSS transmission between the BiSS master in green and from the BiSS slave in blue. And on the bottom, you can see the transmission of between the BiSS slave and the connected BiSS C sensor or actuator. As long as there is no active BiSS communication ongoing, the BiSS master will transmit an idle symbol. This idle symbol consists of an alternating high and low level and is used by the other participants for clock recovery. As described before, robustness is very important for BiSS, and robustness starts in BiSS with the start symbol. The start symbol is selected in a specific way that the Hamming distance is always above 5 until the full start symbol has been received by the BiSS slave. This ensures detection of the start of a BiSS frame, even in rough environments. Since the process data request event is asynchronous to the BiSS signal, the BiSS master is able to measure the delay between the process data request trigger event and the BiSS signal and transmits it as part of the request delay symbol. The request delay is then forwarded by the BiSS slave to the connected BiSS C sensors and actuators. This ensures a low position jitter. Furthermore, in the request delay symbol, 1 bit of control data is transmitted from the BiSS master to the slave. It is then also forwarded to the connected sensors and actuators. In BiSS 2 types of data can be transmitted. Actuator data, which is transmitted by the BiSS master to the BiSS slave and then forwarded to the connected actuators, and sensor data, which comes from the sensors and are then forwarded by the BiSS slave back to the BiSS master. Up to 8 data channels can be configured with a data length of up to 64-bit and a CRC of up to 16-bit. The data is protected by a forward error correction. It enables correction of up to 4 bytes of one process data frame. As mentioned before, there's 1 bit of control data transmitted by the BiSS master to the connected sensors and actuators, and the response of the connected sensor or actuator is contained in the response symbol. There are 2 types of response symbols which correspond to the value of the CDS bit. Okay, now let's focus on the auxiliary data frame. It enables advanced features which can be used to access the BiSS Line slave's registers. That can be used for configuration of a BiSS Line slave, for fast reading of an electronic data sheet, and is required for establishing bus topologies by configuring all the connected BiSS Line slaves according to the BiSS Line setup. It is notable that no access to the registers of a BiSS C sensor can be achieved by auxiliary data frames. To this end, we still have to use process data frames. As for the process data frame, the auxiliary data frame also starts with a robust start symbol. Then the BiSS Line master transmits an opcode, which is specific for the defined operation, which shall be performed by the BiSS Line slave. And the BiSS Line master transmits a BiSS Line unique identifier, which addresses a specific BiSS Line slave in the system. Then the auxiliary data is transmitted, which depends on the specific operation, and the auxiliary data is protected by 16-bit CRC, and the whole data content, including opcode and BiSS Line unique identifier, are protected by the forward error correction. The BiSS Line slave responds with its response symbol, which is the start symbol for the BiSS Line slave, and then sends a status symbol, which depends on the current operation and the status of your operation. Afterwards, the BiSS Line slave repeats its BiSS Line unique identifier and transmits the requested auxiliary data, which is also protected by a CRC and the forward error correction. All right, now I would like to focus on the iC-BL, the bridge component for BiSS Line. First of all, iC-BL can be used as both a BiSS Line master or a BiSS Line slave. There's only one configuration parameter which defines the function within the BiSS Line system. iC-BL can be used in 2-wire and 4-wire communication setups, since the 2-wire setup only requires additional components for the coupling and decoupling of the modulated data and power signal. Space and cost saving, the RS485 transceiver is already on chip. iC-BL is supplied by a 5-volt or 7 to 30 volt supply and requires a current of typically 10 to 15 milliampere without any load connected to iC-BL. iC-BL is further able to generate a sensor supply voltage for the connected sensors, but also actuators. The user can select the supply voltage between 2.5, 3.3, and 5 volt. iC-BL also provides a digital I/O port and crossbar with 10 pins. These 10 pins can be different functions and features can be assigned to these 10 pins. For example, a BiSS SSI master interface, an SPI master interface, an I2C master interface, and an SPI slave interface. iC-BL also comes with a one-time programmable memory on chip. It can be used for configuring iC-BL for up to 3 sensors and actuators, and therefore no external EEPROM device is required in those cases. Last but not least, iC-BL comes in a 5mm x 5mm QFN28 package. Let's take a closer look on possible applications using iC-BL. On the left side, you can see the BiSS Line master device in green, which contains iC-BL, an oscillator, and additional components for the modulation of the power and data signal. On the right side, in blue, you can see the BiSS Line slave device, which also contains an iC-BL, an oscillator, and the coupling elements for the demodulation. To the right, you can see a BiSS C sensor and an I2C sensor, which are connected to iC-BL. For the BiSS C sensor, a process data channel is configured in iC-BL, which means that the whole data content is transmitted within one process data frame. The data of the iC sensor is stored within a register of iC-BL. So to access this register, control communication can be used. This means that there's one bit of control data transmitted within one process data frame, and it takes several process data frames to transmit the whole data of the iC sensor. So this application setup is suitable for iC sensors with a low update rate, for example, temperature sensors. In my second application setup, I have replaced the iC sensor by an SPI sensor. In this case, an acceleration sensor. In this case, I configured two data channels in iC-BL, one for the BiSS C sensor and one for the SPI sensor. Therefore, the data of both sensors is transmitted within one process data frame. This application example is perfectly suitable for condition monitoring, where I need additional sensor content to be transmitted back to the BiSS Line master. In my third setup, I have established a robust link between two microcontroller units. On the left side, you can see one microcontroller unit connected to the BiSS Line master, and on the right side, you can see the BiSS Line, a microcontroller unit connected to the BiSS Line slave. The microcontroller at the BiSS Line master transmits actuator data to the microcontroller at the BiSS Line slave, and the microcontroller at the BiSS Line slave can transmit sensor data back to the microcontroller at the BiSS Line master. This setup is perfectly suitable to connect two or several microcontroller units in a very, even in disturbed environments, for example, in applications like a construction machinery. Now I would like to present you the evaluation kits. On the left side, you can see the BiSS Line master PC adapter, which is similar to our BiSS C master adapters, for example, the MB5U, that you probably already know. The BiSS Line master PC adapter is suitable for 2-wire and 4-wire communication and is connected to the PC using USB. In the center, you can see two modules, one for the 2-wire setup and one for the 4-wire communication. It is a BiSS Line slave module suitable to connect BiSS C sensors like our evaluation kits for our sensors directly to this module. On the right side, you can see the BiSS Line evaluation board. It is suitable for both BiSS Line master and slave operation, for 2-wire and 4-wire communication, and enables accesses to all the I/O pins of iC-BL. All right, enough of the theory. I bet most of you have already an application in mind where BiSS Line can fit into, and I'm going to show you right now how easy it is to establish a BiSS Line communication system using our evaluation kits and software. All right, over here you can see that I have a BiSS Line master PC adapter, which is simply connected to my PC using USB. Here I have a BiSS Line slave module, which will also act as a BiSS C master device and is connected to my BiSS Line master with a very basic 2-wire cable. And then you can see our BiSS C sensor, which is an iC-MHM. It is an absolute magnetic encoder IC and will provide me position data in this evaluation setup. So I simply connect it to my BiSS Line slave module, and then I can start with my presentation in the software GUI. All right, I'm now sharing my screen, so you can join me on this evaluation. And here you can see the software GUI. On the left side, you can see the Connections tab, where the modules will be listed, which I use in this BiSS Line evaluation setup. In the center, you can see the configuration tabs, for example, for the data channel configuration, but also the parameters and registers of my different components. And above, you will see the data, which is transmitted by my sensor. All right, let's start to connect the setup. So I first select my BiSS Line master, which shall be connected. And in my setup, I use a 2-wire setup, which is powered by a USB port of my PC. I simply need to connect my BiSS Line master. Then I simply connect my BiSS Line slave. And since I have used this setup before, a data channel is already connected, which corresponds to my BiSS C slave. Then I simply need to configure my data channel. And in my case, my IC-MHM provides a 12-bit position, 1 bit of error, and a warning bit. And the data is protected by a 6-bit CRC. So I simply need to configure both my BiSS Line master and slave by clicking on Write Data Channel Configuration, and that's actually it. So now we have established a BiSS Line system, and we can start reading the data of the sensor. So in this window, you can see that the mechanical revolution corresponds to the displayed revolution in my software GUI. So in my case, there's no error indicated. However, if I have an issue on the BiSS Line communication, then an error will be indicated here, and I can check the cause of this error in my status window. Furthermore, I can also check the internal frame counters of iC-BL, which contains a process data frame counter, which is incremented with every single process data frame received by the BiSS Line master. And below, you can see the number of corrected process data frames, which have been corrected by forward error correction. I can also access the registers of the connected BiSS C sensor. To this end, I select the registers which are implemented in my iC-MHM, and then I can simply start reading the registers. As you can see, it is quite slow to access these registers. This is due to the control communication, which is only performed with 1 bit per process data frame. If I compare that with my access to the BiSS Line slave registers, once again, I select the registers which are implemented in iC-BL, and then start reading the registers of iC-BL. You can see it is way faster. This is due to the auxiliary data frames, which are used for register access to the BiSS Line slave, and which interrupt the process data frame transmission. All right, so I'm quite happy with my setup already. I have no issues indicated, and it was quite easy to set it up. However, if I want to further evaluate BiSS Line, I might need to adjust the parameters of my BiSS Line slave. And here I have a parameters tab where I can directly access the registers and adjust them according to my needs. Once I've found my configuration, I can simply save a configuration file. To this end, we use a YAML file format, which is quite easy to read. It offers the parameters in a readable, as defined in the iC-BL datasheet, and the corresponding and configured values right next to it. So it is quite easy to check the configuration using this configuration file. Furthermore, I can use this configuration file to simply to use it during production to configure my BiSS Line slave modules. All right, now I will present you a second setup for the BiSS Line master evaluation. To this end, I disconnect my current setup in the software. All right, and now I can disconnect also my hardware. So what I'm doing now is to replace my BL1U, my BiSS Line Master PC adapter, with a BL1D, which is my BiSS Line evaluation board. My BiSS Line evaluation board will be configured as a BiSS Line master, and my iC-BL will also be an SPI slave for my SPI master PC adapter. In this evaluation setup, I need an external supply since my adapter is not able to provide the required current. So I start my laboratory power supply right now with a 10-volt supply for the whole setup. And now I connect my MB3U I2C adapter, which is my SPI master. All right, that's it. We can now switch to the software again. And I'm going to share my screen. And here we go. It is quite similar to the previous setup. So I simply need to select my MB3U I2C, which is my adapter, and my BL1D, which is my BiSS Line evaluation board. And then I click on Connect. I get an information that I now have to supply this board and setup externally, and that I should check the jumper settings in advance. So I've done that before, so nothing to take care about right now. But there's another message which explains me that the BiSS Line evaluation board, which is a BiSS Line slave on default, will now be automatically configured as a BiSS Line master. I continue, and now in the background, my BiSS Line evaluation board is configured as a BiSS Line master. All right, that took a while, but now we're ready to go. We can now connect our BiSS Line slave once again, and the connected BiSS sensor is also connected as a data channel. Since my setup has not changed, I can use and reuse the configuration that I have used before, and simply write the data channel configuration to my BiSS Line master and my BiSS Line slave. That's it. We're now ready to go and read the position data. Once again, you can see that the mechanical revolution corresponds to the display in the software GUI. Furthermore, the process data frame counter also indicates that we have received process data frames, and no process data frames have been corrected with forward error correction. I can do the same things I've done before. I can access the registers of the BiSS C slave, of the BiSS Line slave, as well as the parameters, and also of the BiSS Line master. So in this setup, if you want to check how your BiSS Line master needs to be configured, you can also access the parameters and adjust them according to your needs. Once again, you can store the configuration as a comfortable YAML file format, and then that's it. Actually, you can use this configuration file. You can simply use this configuration file for your further evaluation. You can replace the SPI adapter by your own microcontroller unit using this configuration file and our provided iC-BL microcontroller driver package, which contains the registers and parameter names of iC-BL, as well as predefined functions to access registers and parameters. All right. Now we can continue with my last slide. All right. With my last slide, I'm going to summarize the most important key facts about today's presentation. I think I was able to show you the techniques of a robust power and data transmission using BiSS Line. I think I was able to show you that BiSS Line is fully compatible with all the BiSS C functions and features. and I was able to show you that iC-BL eases BiSS Line implementations into any device and platform, both for BiSS Line master devices and BiSS Line slave devices. Furthermore, our evaluation kits and software supports you during the evaluation and implementation and simplifies the implementation for you. So if you have any further requests, please do not hesitate to contact us and discuss how iC-BL can fit into your application. Thank you, and now we switch to your questions and our answers.
Thank you, Marcel. Excellent presentation. So, Marcel, you have now finished exactly on time, so I just want to tell the audience that we will carry on with the questions. Should you have to leave, this session is recorded and you can listen to the questions after. So, without further notice, Marcel, I'll take the questions here for you.
All right.
So, what is the additional delay of BiSS Line in comparison of using BiSS C with 6 wires directly? What's the difference?
Okay. Yeah, so there is, of course, a delay, a latency, which is induced by the BiSS Line. It is typically, it of course depends on the transmission line length, but it's typically about 2 to 3 microseconds.
Okay, thank you, Marcel. Next question. In the key facts slide, the supply voltage is 5 volts or between 7 and 30 volts. What would happen between 5 and 7?
That's a good question. Well, it is out of specification, so I would not risk it. We can discuss that closer, but I wouldn't do that since it's not specified and therefore not tested.
Okay, good. When will the iC be on the market? Is there already a demo board? Can the power over line works without the transformators? What's the smallest size? As you have many questions here. So let's start with the first one, time to market.
Yeah, okay. So we are ready to go. iC-BL is already available. You can purchase your samples, and you can also purchase our evaluation kits, which I've presented you today. And we will also provide you with software as well as our iC-BL driver. So we are ready to go, and I hope you are ready to go too.
Okay, and I'll take the second sub-question here. Can the power over line work without the transformators?
Without the transformator, yes, that could be possible, but it is not recommended. So the coupling elements that we have shown, including the transformator, is our recommendation for a typical BiSS Line system setup, which also protects the circuitry. There might be adjustments possible, but please get in touch with us directly so we can discuss it specifically regarding your application.
So the last sub-question is, what size of transformator what's the smallest size you can use for this?
All right. So it really depends on the application, but it might be possible to remove the transformator completely. As described before, we have to discuss that in detail with respect to your specific application.
Okay, excellent. The next question is about cable. So what requirements are defined for the cable? Mm-hmm. Shall it be twisted or shielded?
Yeah, so in best case, both, but it also depends on the application. If you have long transmission lines, if you have a huge PWM signal on the same line, then you need to protect the data signals. In other applications with low voltages or in a very basic setup like this, the requirements are not that strict. So you need to adjust the requirements on the cable depending on the application. Using a twisted pair is always a good idea and absolutely recommended for this setup.
Okay, thank you. The next questions are the connectors for BiSS Line fixed by some standard. What are the typical connectors?
All right, we do not have defined connectors for BiSS Line. So the hardware is actually open. You can use connectors which you want to use. There's no real standard. Yeah, only the protocol is defined, and you can, of course, check out our evaluation boards, the connectors we use, but also the standard connectors which are used in M8 or M12 cables.
Okay, thank you, Marcel. The next question is it possible to connect more than one slave to the BiSS master?
Yes, so it is possible to connect several BiSS Line slaves to one BiSS Line master using the BiSS Line protocol. For your application using iC-BL, I would recommend to get in touch directly, since our software is not yet ready to use to provide a setup with several BiSS Line slaves connected to one BiSS Line master.
Excellent, thank you. We carry on the next question. Is there an available IP core for BiSS 2-wire master and FPGA?
So it does not depend on the 2-wire or 4-wire communication, but the BiSS Line master IP core is available for FPGA implementations. You can directly contact us and we will provide you the BiSS Line master IP core.
Okay, thank you, good. Next question, what is the maximum cable length that can be achieved by BiSS Line in 2-wire mode?
Okay, this also does not depend on the 2-wire or 4-wire setup. We specified for a length of 100 meters. In our laboratory, we have also achieved lengths which are a bit longer than the 100 meters. So maybe it is even possible for 120 meters, but specified for up to 100 meters.
Okay, thank you. Next question. What is the turnaround time difference between BiSS C 6-wire and BiSS Line? Meaning starting the request in the BiSS C master until data is available in the BiSS master.
I'm not quite sure about the question. So I think it's about the delay between the BiSS Line slave and the BiSS C communication. So the BiSS Line slave, or iC-BL, works with a clock frequency, internal system clock frequency of 100 megahertz. So the delay of iC-BL is quite low, but it depends, of course, on the connected sensor and its sampling frequency when it is about to start.
Okay, thank you. Next question. Is the BiSS Line protocol description documentation available for download? Does it come together with the evaluation tools?
All right, you can find the BiSS Line protocol description already online on the BiSS Association website. It has just been released, but you will find it in the download section. And of course, for the evaluation kits, you contact iC-Haus directly, since it is part of our product range, and we are going to offer it to you.
Excellent, thank you. Next question. BiSS 2-wire requires some specific line pair impedance, i.e. 120 ohm, is the question.
Okay. Yeah, well, that of course also depends on the transmission line. The 120 ohm are typical for setups like this, and therefore we have also considered it in BiSS Line. So you can find on our evaluation board also the 120 ohm termination resistance at both sides of the BiSS Line.
Okay, excellent. That was the last question I have here, so I wanted to thank the audience for asking many relevant questions. And
Thank you.
Should you have any more questions, feel free to reach out to us and to Marcel in particular. He's our expert, and we look forward to communicating with you and help you in your efforts to support BiSS Line. And Marcel is the expert for this, so he's available for everything. Thank you. So that concludes today's session. I want to thank Marcel for a very interesting proposition here. And before I pass over and end the session, I just want to say to you that please join us at the next upcoming webinars and also for the next trade shows. So there are trade shows coming up here in April. We have one in Munich, the Laser World of Photonics, and then we have Sensor and Test in Nuremberg in May. iC-Haus will be present, and we welcome you to come and see us there and ask us questions. And we look forward to meeting you again after many years of no trade shows. So please come visit us, and thank you for attending, and we look forward to see you soon. Thank you. Bye-bye.
Thank you. Bye.
iC-Haus. Integrated circuits.